Testing sound. Testing. Sound. Testing.
I warned you this would happen. My entire public career
Hello there, everybody. I'm here now. I had a bit of business that cropped up unexpectedly while I was starting the stream, and so I started about 10 or 20 minutes after I intended to. On the plus side, it did prompt me to create that AFK message I've been meaning to create for a while. Minus side, that AFK message is like very limited purpose, and I probably need to come up with another one to use. Yeah. Yes. I should have. I wonder if you can do screen captures with alpha channels. Should be. I mean, there's filters. I could apply an OBS filter to the screen, and then I could use a green screen background to be the alpha channel. That could work. I could do it that way. That might be an option. Then I could write a little program that had an AFK message, and I could set the program up to have a special AFK message or a countdown or whatever it is that I felt the need to put in there. It's an idea. I'll have to consider it. So, what were we doing? Well, I did a few things off stream, but what we were in the process of doing was, in fact, writing a whole big bunch of tests for, and I'm going to close all these tabs here that are basically views into the standard library because I don't really care. It's just that the debugger jumps there when you go through things, and so then the pile pops up even though you don't really care what's there. It'd be nice to just say to the debugger, I don't really care about any line that's technically a part of this file. Please just get to the next assembly language instruction that is not recorded as part of a line in that file. That would be nice. But the writing a bunch of tests, and yeah. So the thing that I did off stream is I changed a whole lot of requires to checks, because there are some things where, well, if the result is null pointer, you can't continue. We require the result to be null pointer. If we didn't delete all the tokens, well, that's just a failure too profound to really trust any of the rest of the output. We don't really care whether it's good or not, and so fail then. But if the eval result wasn't great, well, we still might care about the range equal, and if the up above, we might care about whether the string representations that we're looking for show up correctly and stuff like that. So I should. That's what I changed everything to checks for, is so that just because a test failed doesn't mean that the rest of the test is aborted. And so this check here, this require here will cause none of the following checks to be evaluated, but any one of these checks that fail, they will just cause the next one to not work quite right, or cause the next one still to be executed. I'm thinking that yep. And this, I wonder if there's a way to revert the line. Yep, there is. Except I want to. Well, that's interesting. This should still work. And I want to keep this, except I'm going to be putting in a big change here that causes a whole big bunch of lines to change, but it's all the same change, all related to each other. And so, yeah, let's make sure. I probably want to commit this change, this check change. So let's try just this change here that changes all these checks. And then we will do the rest of them later. Yes. And then test parser test.cpp. -I allows me to say yes or no to each individual change. Let's see here. And yeah. So yes, I want this change. 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 I'm just trying to spot check that I didn't actually change any of the text of the tests. And yes, I want this change. 5. Yes, I want this change. 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 Yes, I want that change. Yes, I want that change. No, I don't want this change. No, I don't want that change. Yes, I do want that change, even though it's inside that if def out thing. No, I don't want that change. Yes, I want that change. Yes, I want that change. That change. Okay. Now we're doing a bunch of stuff here. Yeah. Okay. I did that and switched up to this. Okay, so let's try running our tests. Okay, so we still have some failing tests, but all the tests that are failing are basically bad formatting problems. So, and I actually need to go through and redo the formatting anyway. So, is this effectively correct, though? So yes, it is correct. It's just got new lines in poor places, and I can fix that. I won't fix that right now, but I can fix that later. But what I can do until then is I can so it's the here, this one. So here we have okay, I have that. What happens if I do that now? Again, if 0, oh, no, this one, prog n, if 1, prog n, like that, that's right, 42, close, close, and there's an extra backslash n in here. Will that make it work? Okay, we'll try enabling this silly feature. What the heck? Let's see what happens when I do that. Okay. So now we only have one failed, so we managed to get this test to succeed. Now we have this one here. If 0 prog n 42, we don't want the backslash n here. Double close, then we need 2 backslash n's here. I bet this will be correct. I updated CLion, which is one of the reasons I was asking me about this silly feature. Oh, it also needs another backslash n. It needs to not have this backslash n in there. Okay. Now, one of the questions is from a Lisp syntax standpoint, is this correct, right? And so, prog n 24, close paren. So that's closing that if, then that's closing that prog n. So, yes, this is correct. And the same one with the other one that I went in and edited. All right, if 142, right? If 142, doink, 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 doink. Yep, that's all correct. So, all correct. I'm going to have to think about how to make the output thingy a little more intelligent about code formatting on output. So what did we do? So this was kind of a big change. First thing we did is we changed the grammar around. So does the grammar comment represent the actual grammar correctly now? Let's ask the AI what it thinks. And also, too, I wonder, does it have any new AI models in here? Reasoning model supports images. Other models. Huh. I could switch to GPT-5, but I like Claude. At least here, I like Claude. Wow, it's just pulling in tons of stuff here. In fact, it looks like it's pulling in. I don't know where this fuzz tech test spec parser is coming from. Apparently, there's some kind of fuzzing built into Catch 2 nowadays. Oh, it is a significant discrepancy. This is true. Just a bit. As I go deal with toast. And done with the toast. In fact, I've gotten rid of the toast. So my grammar is wrong about one thing here. And I need to change this so that well, is that true? Expression is expression or bool term. it's wrong about this. It got it wrong. Bool term equals. So it got it wrong. One, of course, ampersand ampersand having higher precedence than or. It's totally wrong about that. And it's also wrong about what the tests expect. So it's wrong about this. And so it did the analysis incorrectly. And it wasn't what I was hoping to look for anyway. So AI fail here. But on the other hand, what's kind of amusing, of course, is then that in C, oh, hello there, your indicator. How are you this afternoon or evening? Probably evening, unless you're in an odd part of the world. Dual streaming. Let me check what scene is showing. Oh. Something is going wrong here. Yes. I changed scenes, but the change of scene is not showing up. The way it's supposed to. Oh, stupid annoying. So let me try this again. Okay, we'll try this one more time. Well, that's really obnoxious. OBS is misbehaving in a way that I'm not entirely pleased with. Yeah, so I do have scenes defined for chatting and programming and AFK, and it's showing you a bizarre combination. It's showing you like the AFK screen plus something else. And so I don't know why it's doing that. Okay, that's what this is supposed to be right here, right? This is the camera. This is the background. But the screen capture is not... One, it's not actually... Well, that's kind of interesting. There. I should have double checked to make sure that things were working correctly. So there we go. Thanks for saying something. Oh, I have a command line utility that I use on a separate computer to do the scene switch. There, see? That's what it was supposed to have been showing all this time. I'm using screen capture to get all of this stuff here, right? My sea lion screen and all of that. And for some reason or other, the screen capture part got stuck on the AFK screen for some unknown reason. Oh, that's a way to do it. I just have a laptop, and the laptop has an SSH connection to the computer that I'm using to do the streaming, and I just run a little Python command line utility that talks to the OBS WebSocket API and tell it which scene I want. The advantages of having two computers. Anyway, I just had AI analyze this pseudo BNF against my code, and it got so many things wrong. Like, it thinks that this code assumes that the precedence of ampersand of the Boolean AND is going to be higher than the precedence of Boolean OR, which is not true, actually. I specifically designed this test. Just a second. We have a fire truck. It decided that this was supposed to, this test was supposed to test that this was higher precedence than the OR. And the test, in fact, explicitly tests for that to not be the case, for them to be the same precedence and be evaluated left to right. And it also thinks that this grammar, for some reason or other, makes the Booleans have a higher precedence than all the arithmetic operations. And that's not true. The Boolean has a lower precedence than all the arithmetic operations. I should be consistent here and use the same symbol instead of equals. I should either use equals, or I'm going to use equals everywhere here. And actually, we're going to do a special commit just for this change, because it is a tiny little change that has no semantic meaning. What? Hey. Where is the change to the comment? There is a change. There we go. The laptop only struggles after a while because Firefox has a memory leak. And so I basically periodically need to either shut down Firefox or kill a bunch of the tabs. And then everything's great again. The other thing I have to do to it is periodically restart GNOME Shell. And then it works. More self-consistent. So, yes, that change. Yes, that change. Not that change. Okay. Well, in C, double ampersand is higher precedence than OR. And in most other languages, logical AND will have a higher precedence than logical OR. It's not so much the. Well, I don't know what you mean by cache. If you mean files on the disk, then no, that won't help. If you mean some kind of in-memory data structure that I would have to execute some JavaScript in Firefox to clear out, I mean, I guess, one, I would have to learn a whole lot of JavaScript to figure out how to write one myself, or I'd have to find one that somebody else wrote, and then I'd have to learn a lot about Firefox to learn how to get the JavaScript to do what it's supposed to do, if it's even possible to get it to do the right thing. And so, I don't know. No, they're not the same thing. And the thing that's specifically a problem is memory usage, the usage of actual physical RAM, of RAM, not hard drive space. The hard drive space, I have so much hard drive space, I don't care how much Firefox uses for the most part. So, in most languages, the logical ampersand, the logical and has a higher precedence than logical or. But I'm just writing my own grammar, right? So I can decide whatever I want to. And I decided they'll have the same precedence. Because this is toy. This is not intended to be a real programming language. This is intended as, hey, can I use CTRE, which is compile time regular expressions. It's a very clever regular expression library by Hana Dusíková for C++. And so there's compile. I'm testing it to find out whether I can use that as the tokenizer and then write a parser for a very simple language. And I wanted to make the language complex enough to be at least a little bit interesting. And so that's why I'm going to be introducing ifs and then loops and statement blocks. And I probably should add relational operators because it's really hard to work with ifs if you don't have relational operators, which I don't have right now. And so, yeah. And then once I get it to actually have like some kind of looping construct, I'll be done. Maybe I will implement functions. But then once I implement functions, I'll have to add types because right now all identifiers are ints. So, yeah. Unsigned ints, in fact. Unsigned 64-bit ints. And if I add functions, then are functions first-class objects? Well, no, they probably won't be. But then there'll be identifiers that occupy the space of identifiers that can't actually be used in expressions aside from as a function call, which means that there is something of a type. So I might as well have to type. And yeah. So I don't know whether I'll implement functions or not. That's a lot of extra complication. But looping, definitely. And I almost certainly should implement relational operators too. So, are you familiar with the concept of a recursive descent parser? By the way, Claude got this all wrong, which is kind of amusing. I'm not overly surprised that AI analyzed my code and then didn't understand it and made some silly assumptions. Oh, that's actually pretty nifty. Recursive descent, yes. I'll show you how a recursive descent parser, because I will walk you through like the overall structure of the parser here. So here I have all these different things for parsing different productions. And this is a statement about the grammar. Are you familiar with the BNF notation for grammar? That's a good effort. I know that way back then when I didn't know anything about how these kinds of things work, writing a parser would have been a huge undertaking for me, and I probably would have gone all the wrong direction until I read some books on theory about it. Yeah, I mean, there is something to say for doing rather than memorizing. I do a surprisingly good job remembering the stuff that I read or hear, but really the thing that cements whether I know something or not is actually doing, which is one of the reasons why I'm doing this. These are concepts that I've known about for a long time, but I, in fact, have never written a recursive descent parser. I have written parsers before, and I have used things like Yak or Bison to generate parsers. I also use something called parsimonious for Python to generate a parser. Um, yeah, we just had a Banivator come in. I'm going to go into Twitch and tell the Banivator that they're not welcome here. And ban. All right, it's gone. Yay! There's anything that'll guarantee that I never use streamboo.com, despite the fact that I consider what streamboo.com to do is somewhat unethical. The fact that they choose to also spam everybody about it is another reason why I will never use it. Also, welcome, Bizrai. So, what country are you from, dear indicator? It's 2 a.m. there, somewhere in Eastern Europe. Yes, Germany. Okay. So BNF is very useful to know about because a lot of programming languages, their grammar is in fact specified by BNF. You can actually find a BNF representation of the programming language's grammar. And that's a big help sometimes in understanding a programming language. And all a grammar is it's a sort of a way of saying how valid statements in the language are constructed. So for me, the top level is sequence. Everything, the entire program is a sequence. And what is a sequence then? Well, a sequence is a statement optionally followed by a sequence. Okay, so what's a statement? Well, a statement is an if statement, or an assignment, or an expression statement, or an open brace followed by a sequence followed by a closed brace. Oh, okay. So, an if statement then. What's an if statement? Well, it's the keyword if, followed by an open paren, followed by an expression, followed by a closed paren, followed by a statement, optionally followed by the else keyword and another statement. And so the BNF Bacchus Nor form, Bacchus Nor? N-A-U-R form is basically a statement of how valid expressions or valid programs in this programming language are constructed. Like, what are the rules for how they're supposed to go together? And so, like, it talks about braces. Braces, you can have brace enclosed sequences as being a statement. And if statements demand an expression here, very specifically in between the parentheses, and you have a parenthesis here for this statement. Now I could actually say if expression and then like some other kind of separator statement. I could have done it that way, but I didn't. I just, like Python has a colon here, and no open paren, and so on and so forth. Like this just describes, and then at the very lowest level, what's it a factor? A factor is an identifier, which is a token. And this also depends on there being a bunch of tokens. And I have the regular expressions describing what these tokens look like over here. And so, yeah. That's what BNF is. Yep. So I believe that BNF was actually, don't know if it was created by, but I do know that this area of theory actually has a strong overlap with linguistics, and you'll actually start running into things that good old, what's his name, communist linguist person, who people really like to quote. What is his name now? It escapes me. It's not that important, but I really like being able to like recall these things when I'm trying to recall them, and so I'm going to go look it up. Noam Chomsky, that's it. You'll start running into Noam Chomsky pretty quickly once you start looking into that area of things. Hello there, Sky. So anyway, the way a recursive descent parser works is a recursive descent parser starts with the idea, okay, you're going to parse the top level statement. So what are the possibilities for the top level statement? And so then you look, okay, the top level statement consists of a statement, the top level thing consists of a statement or followed by optionally more of the top level thing. And so then you just implement it like this, right? You say, okay, well, I'm expecting a statement here, so we'll try and grab a statement. And if, while we haven't consumed all the tokens, we'll check, can we grab another statement? And if we can't grab another statement, then we stop. Otherwise, we add it to our list of statements. And we say that, we start at the spot where we got to the end of the last statement. And then we return our list, the total list of statements that we made. Fire truck again, just a bit. Perils of living near the the Oh, I actually also largely just abort on error. I have no effective error handling in this thing right now. But then we get to other parts of the recursive descent parser that are a little more interesting. Like this parser for the sequence is obvious, right? But notice how if something fails, it just kind of stops parsing. I should actually have it check here if start is equal to finish, because if start isn't equal to finish, then something went wrong and it should actually return an error instead of doing this. But I don't. I just return as much as I was able to parse. And I pretend I was able to parse all of it. But like this statement here is more interesting, right? Because statement might be one of several things. So I go and I look. I first, here when I'm trying to parse a statement out, I try to say, oh, is this an if statement? Like, let's see if it's an if, try to parse it as an if statement. Well, first I look, is the next token I'm looking at an if? Because if the next token I'm looking at is an if, then I should try to parse it as an if statement. I could have just said, let's try parsing it as an if statement, and had in fact, that's probably what I should have done, is call the parse if statement thing, and then had the parse if statement thing go, nope, it's not an if statement, as soon as it saw that the next token was not if. But that's basically what I'm doing here. Okay, let's try it as an if statement. If it's not an if statement, let's see, is it an if else? Oh. Oh, no. This isn't actually looking for if statement at all. This is looking to see, if it found a curly bracket open. Okay, that's actually fairly reasonable. Because one of the things a statement can be is a curly bracket followed by a sequence. So here it sees, am I looking at a curly bracket? Then am I able to parse a sequence? That's great. Then after I parse the sequence, am I then looking at another curly bracket? Okay, then that's great. I've just parsed a sequence, and that's great, or as a statement. And so there is my statement right there. And then it's done, right? So at first it tries that. And if that doesn't succeed, sadly, this else if is the wrong thing to do here. I can think I might be able to construct something. Anyway, let's pretend the else if isn't the wrong thing to do. Else, if it can't do that, then actually it still is the right thing to do, because if it sees an open curly bracket, the only thing it could possibly be is when it's being told to parse a statement, the only thing it could possibly be is a curly bracket enclosed sequence. And if it's not that, then that's a failure anyway, and so we'll just fail totally. We don't need to go check to find out if we're looking at any of these other things. But if the first thing isn't a curly brace, it goes, well, it can't possibly be a curly brace and closed sequence then. So let's see if it's an if-else construct. And if it isn't an if-else construct, if that fails, then it goes, well, maybe it's an assignment. Let's see if it can see it as an assignment. And if it can't do that, then it goes, oh, all right, then let's see if it's an expression. And if it can't do that, then it fails. But otherwise, that's what it does. And actually, one of the things I need to do here is I need to have after being equal to finish. There we go. Basically, to make it fail properly, if it actually wasn't able to parse everything. And finish is indeed a toklist iterator. Yeah. So why are you complaining here? Oh. No, I'm not going to do that here. No. Sorry. Looking at what CLion tells me that it should do. So that's the way a recursive descent parser works, is that every step along the way, it checks out, okay, I'm here. In this part of the grammar, what's next? Does it fit? If it doesn't fit, then we just go, okay, then I failed. And then the top level tries the next thing, if there is a next thing to try. And so it basically recursively descends through the BNF, parsing out everything it can, and then it eventually gets a full parse. There is a different kind of parser that's a lot more elaborate to construct, and it's also more efficient. One of the things that can happen with a recursive descent parser, this one won't do that because I very cleverly organized both the grammar and the way it's doing things. It always looks ahead just enough to figure out which branch to go down. You can always make specialized parsers for very particular kinds of things that don't operate in that fashion. But recursive descent is a general approach that you can take where you can turn almost anything that you can express as a BNF grammar into a parse tree. And so that's the reason why I like it, is because, it's that flexible. There is another thing that this is kind of pretending to be. As I said, recursive descent parsers, one of the problems that they can have is, you go all the way down and you are parsing a whole big bunch of things, then you realize, oh no, this isn't really a statement at all, it's a something else. And at the very bottom, you don't know that, you just know, it isn't the thing I'm trying to parse right now, and you abort and fail all the way up. And then, so you've done a whole lot of work parsing this thing, but you've parsed the wrong thing. And then you have to try to parse it as the right thing, because, maybe it's still valid. In this case, this is very cleverly avoided by things like this brace detection here, right? Or the if-else, the first thing it checks is there an if keyword? So it knows at the very beginning whether or not it can be parsed as the thing that I'm trying to parse it as. And so it doesn't actually have to go down the tree at all. But that is a problem with recursive descent parsers, is if you don't code them well and your grammar isn't reasonably well designed, you can have recursive descent parsers that do a whole lot of parsing work only to realize that it was all for naught and they should have gone down a different branch of the tree here. There is another kind of parser that I don't know how to describe the function of, and of course I don't have the code for it, called an LALR1 parser. And most, like the Bison parser generator, that's what it generates. And these parsers have a fairly sophisticated system involving looking ahead a certain number of tokens. LALR1 is one token, look ahead, along with a bunch of other things to, do parsing. They are incapable of parsing any. There are many valid BNF specifications. There are many valid BNF specifications that LALR1 parsers cannot parse. And so they are not as flexible. On the other hand, most BNF specifications that anybody would actually want to use as a programming language can be parsed with an LALR1 parser. Interestingly enough, C++ cannot be parsed with an LALR1 parser. It used to be that there was only one problem, which is the way if-else statements worked, which is actually a problem that happens in a lot of curly brace languages. But then it got to be that it was there are other constructs that started showing up as ambiguous, like is this a function declaration or is it a constructor? Various things like that. And yeah, so they end up having to go to a recursive descent parser for C++. So at least for GCC. I don't know what GCC is exactly now, but GCC I do remember very distinctly about 15, 20 years ago actually went and changed implementations from being an LALR1 parser to being a recursive descent parser. Because, as I said, C++ introduced a lot of ambiguities in the grammar that couldn't be resolved properly by an LALR1 parser. So, anyway. So what changes did I make here? What I did here is I extracted parsing of a statement out of parsing of a sequence. Let's see what, if I ask the AI to generate a changelog for me. I'm always curious what it does. It almost always does a terrible job, but I'm always curious. Yeah, that's a dumb changelog statement. It's very generic. Also, now This needs to be 68 characters or less. It is not. It is 71 characters. I need to remove a few characters. I like my changelog messages to be very short, but also fully explain what the change is about. And a one-line thing. And I want it to be a certain width so that if somebody is looking at it on an 80-column screen, somebody is still using punch cards. So I managed to get it to be short enough without your suggestion, but your idea of removing more characters would be helpful if I needed to make it longer. So thank you. Yeah. But that's the gist of the... Let's see. Is there anything more to it than that? No, not. This is part of that. This is part of that. Part of that. No. Okay, so we will actually use yours. Yeah, this is good enough. I don't really have to say that I fixed a couple of the tests because the fixes are pretty unimportant. There we go. So I like them to be short, but then also too I put this for ones where there's more to the story. I could have done that. I think it's good enough. I don't really think the fix is basically changing a couple of strings to match the actual output. Even though the actual output is not what I would like it to be. It's not exactly wrong. It's just not right either. But I did it. Also, too, the result is 42, which is the way it's supposed to be. One of the things is the result of a statement is the value of the statement. The result of an assignment statement is always 0. And so the result of this is going to be whatever the last thing executed is. Like if 042 is going to be 0. I could make it else something. But yeah. Oh. This is an annoying feature. I have focus follows mouse turned on, and this thing, JetBrains, does not like focus follows mouse. And so I occasionally have to click off the window and then back on again. So that worked. And the test passed too. Well, what do you know? And if 1, x equals 10, else x equals 20, x, and the result should be 10, and the statement should be 0, 0, because all the assignment statements are 0. This works, and the problem is I want one where the else clause is the value that is taken. So we're going to make one more test here. There we go. Else x times 2. So the result should be 4. There. That works. That works. We got 4. Okay. We've got a full set of tests. Yeah, I could have just if and then a false and then an else and then something, but we do actually already have one up here that does that. X equals 2, if x minus 2, which is going to be 0, which is going to be false, then we'll go, well, not this one, but this one. And x plus 10 is 12, and x times 2 is 4, and we're trying to make sure that the result is 4. And actually, I also have something that I have a version of the evaluator that actually saves the result of every statement that's executed. And so it will save, the x equals 2, the result is 0, because assignment statements, that's what the result is. But then the if statement, the result is going to be whichever branch is executed, and in this case, x times 2, so the result is going to be 4. So I have this one, this is a way to check to make sure that every statement got a answer that I'm happy with. Which is also, the reason why I did it is because this one I had all these tests and I wanted to make sure that blah, 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 blah was all correct. So, and that works. So we got it. That's true. I haven't explored some of its more exotic customization features as much as I should have. One thing I would like to do is change, have a custom indentation system, because, for example, I like doing this, right? And there's a couple of other little things that I like doing that this does not do. And so I would like to go through and try and fix it so that it does those things. Which I think I have to use the Clang format one. Because there's one that is built in and then there's the Clang format one. And I don't think the built-in one is flexible enough to do some of the things that I want to do. The focus follows mouse preference is actually a preference for the, I'm using Linux, Wayland. It's a preference for the GNOME shell Wayland window manager. And so it's outside of JetBrains that the focus follows mouse happens. The thing that's happening is that JetBrains gets confused about whether it has focus or not. So like here, if I press the arrow key, for example, it has focus. And if I do just the wrong thing, they can get into a state where it doesn't think it has focus. And so it ignores all of my keyboard presses, even when the window manager has given it focus. So, yeah, the focus follows mouse is more JetBrains making an assumption about the environment that it's running in that I have falsified. And JetBrains shouldn't be making that assumption. And I don't think I can fix the assumption that JetBrains is making. I think that assumption is buried deep within the Java code that for the way the editor, well, the way the whole thing works. Where it has to believe certain things about getting focus. And if those sequence of events don't happen, it doesn't believe it has focus and ignores all the key press events. So what's the next step here? So I've gotten all these tests to work. I think the next thing I want is relational operators. Relational operators should sit between Boolean operators and what's it says for precedence, mathematical operators. So here's how we're going to do this here. We are going to have a relational clause equals term so is either a term or a rel clause followed by a term. And then bool term is going to be changed into rel clause and then rel clause, like that. So I'm going to be implementing this part here. I would actually be tempted to bring up the little window manager thing that shows you that, but then I would have to bring up more of my desktop that I want to display on the screen right now. So, yes. But, so anyway, so this will cause a bool term to be lower precedence than rel clause, but rel clause to be left to right associative, because of this kind of leftward recursion. Yeah. So the next step about this is to add more tokens. So we will still have equals being its own thing, and we'll have to have a special check for it, sadly. And here, this is the wrong way to do rel up. What we should do, yes, that is what we should do, and not the equal, sadly. Yes. So a relational operator is either a less than, or a greater than, or a less than or equal to, or a greater than or equal to. Okay, let's see here. Base. You know, I think I want to fold. I had equal being its own thing. I think I want to fold equal into being an operator. So how much would I have to fiddle with things in order, because right now bool and, yeah, operator here. I don't need equal to be its own thing here. So this is going to require are you talking about the change that would allow me to mess with the settings, editor, code style? The thing that would allow me to fiddle with the formatting? Oh, interesting. Huh. Aha. So this is part of it. There's another part where I actually get to edit what that means. Ah, here. There. Yes. And I have modified it somewhat. I've told it to not use spaces. And to have my indent size be 3, partly just to frustrate the people who like to use tabs, because people who use tabs these days are evil. And I blame Microsoft for all of it. And naming, header guard style, syntax style, braces layout. So sort include directives. I'm not going to do that. Use forward declarations if possible. Prefer to use forward declarations if possible. Only paths. So there's that. But there's a bunch of other things too. Indentation and alignment, for example. First, what's this spaces about? Oh, spaces before yes. There's that. But then there's indentation and alignment. And one of the things I like here is, for example, there's, what one is it? Access specifiers. So what I want to do with access specifiers is I want to indent them one space, but I get the choice of either indenting them or not indenting them. And that's not what I want. I want the choice to indent them one space. So if you use tabs, you must use 8-space tabs. If you aren't using 8-space tabs, you are basically adopting a non-standard tab stop that will display improperly on anybody who hasn't configured their system to also use 4-space tabs. And the default tab configuration is 8-space tabs absolutely everywhere, except inside of really dumb mess-DOS editors that decided that they were going to have a default of 4, and then everybody started using tabs for their indentation. That is the reason why I absolutely despise tabs for indentation. They are terrible. They make code look incredibly ragged and terrible. Exactly. That's what you do, and you make your code look terrible for everybody who doesn't do that, and nobody does that. Let's look here. STTY-A. Columns, tabs, don't see here. Where is tabs? Tab 0. So if I were to display the tab stops here, there will be a tab stop every 8 spaces. Here. So you can see, by default on this terminal, there's a tab stop at 8 spaces. There's a tab stop at 16 spaces. And then, this is not tabs. These are spaces. And so it doesn't do that. And so that's the default. It's the default everywhere. Everywhere the default is 8, except in stupid, dumb editors that should never have set that as the default and shouldn't have allowed people to change that to be the default. The default is 8. It should be 8 everywhere. That is the reason why I do not like people who use tabs. Like, if the default had stayed 8 everywhere, then I wouldn't care whether people use tabs or not. It wouldn't matter, because your code wouldn't look all ridiculous and ragged when you didn't use tabs, or when you use tabs. But when you set it to 4, your code starts looking really ragged whenever you look at it on anything that's not configured to use your non-default, their standard 4. That's the reason why I do not like tabs. Anyway, the thing that I want to change is this. And this doesn't allow me enough granularity to change it the way I want. I'm wondering if I could actually I'm wondering if I can't get it to use the Clang tidy style. But I don't know. So that's a thing that I want to check out one of these days, is whether I can make it use Clang tidy style. Anyway, tokenizer test. So 1, going to put operators in here. I had to put or in here in this really obnoxious way. I'm going to put equals in here. Move equals out of here. Going to not have a rel op. And we're going to have or dash, or less than or equal to, or greater than or equal to. And we're also going to have less than, greater than in here. There we go. All right then. This is going to actually require a whole lot of modifications to code to make to work. And so we're going to have we're going to have to do all that. Which means we're going to have to make this multi-line. And since I like wrapping at 80, there we go. So I have this nice light line at 80 to try and keep things within 80, which I try to do most of the time. I'm not doing that very much over here in the tests, but I otherwise try to keep it that way most of the time. Now that I've done this, so I've added all these to it, then I also have to change it so that to remove this, because there's no more equal. We'll still treat all these other ones as special. And then we'll have to add a few more cases. This is ugly. I'll leave it, but it's ugly. Anybody want to tell me why it's ugly? No. There we go. That's what I wanted. There we go. Do I want to do it this way? That is what I'll do. And I want to do that, except I also need like that. So less than or equal to, less, greater than or equal to, greater than. We've got equal, got plus minus times divide, we've got bool and bool or. So why is this ugly? This is ugly because of this. This is what makes it ugly. Now, fall through itself doesn't do anything, but it's the logic that causes this to be here. Basically, it's going, if we start with an ampersand, then check, are we an ampersand ampersand? And if we are, everything's great, and we break out of the case statement. Otherwise, we fall through. And we check, are we an or, which we of course are not going to be, because, or a bar, because we're not going to be, because we started with ampersand. So this is also going to be false. Then we're going to fall through, and we're going to unexpected operator. Okay. But then, of course, if it starts with an or, then we check, is it a bar? Is it bar? If it's bar, then well, that's great. We found a Boolean or. Otherwise, we break and we fall through. Or we break and we break out of the case statement. Otherwise, we fall through and go unexpected operator. So basically, this fall through here is just it's a trick. It consumes slightly more computation than but the other thing it does is it's just ugly. But it works. I'm going to leave it there. Probably replace it one of these days with something that's a little less ugly. Although I really would like to have just one place where I'm exerting about an unexpected operator. And the reason why I'm asserting here rather than throwing an error is because this is a programmer error. Because this means the regular expression somehow matched something that it called an operator, and then the operator wasn't any of the things that the regular expression should have matched. And so that's indication that there's a programming error, like somebody modified the regular expression and didn't update this or something like that. And so, or the regular expression is wrong, or any number of things. So it's a programming error, and it's therefore an assert failure. Not a person typed in the wrong program and caused my program to assert fail. That shouldn't be like you. A parser shouldn't assert fail just because someone typed the wrong thing into it. It should fail, because that's a semi-expected condition. Okay. Now I have to go back through and find out everywhere where it said equals. Right? Now what I could do and then require like that. I could do that. Yep, that's what needs to happen here. Yep, just like that. I love AI for some things. For this kind of thing, it makes the editing task easier. I could have, if I were using Emacs, I can probably do this with CLion, but I don't know how. Oops. Well, you missed some scintillating conversation, Sky. The soothing tone of my voice. I don't have to make the macro that does this. But in Emacs, I could really easily, and probably if I knew CLion better, I could do it in CLion too. Not see here. What's next after this? Yep. We'll try this again. Operator. Like that. And then next. Okay, that's all good. Now let's try parser test, and here we are no parser. Here we will also have equal. And holds alternative tokens. Yes, that's exactly. Yes, that's how that should go. And I don't know if I will have it anywhere else, actually. Yep. Let's see. Let's try and build it now. Oh. No cheese. Sadly. All my cheese is in the fridge. That would have been an excellent idea, though. I should remember that. I have some very nice brie in the fridge. And earlier I was like thinking about something to eat, and I went out and got something, a very small snack to eat. But I could have just put some brie on a cracker and eaten that. That would have been pretty good. But I did not. Okay, so it compiles. Let's see if the tests run. I love having tests, because now all the tests run. I know this major refactoring where I added all of these things to it. 2. And then I can add, because I want to be more elaborate. Own kind of token. There. So add tokenizing for relational operators, move equal to operators, and then I have a lot more detailed explanation about what I'm doing, but this one line is enough to describe the fundamental basis, like what the most important change is here. And then the rest of this is just explanation and more detail on the change. I want to find out what AI decided I did about this. I always like doing this just because it amuses me how wrong it is oftentimes. All right. It was good having you on the Steam, Dir Indicator. I hope to see you again. Maybe I'll try streaming a little bit earlier next time. I try streaming on Thursdays, Saturdays, and Mondays. I don't always make every day, but that's when I try to do it. I will try to get to be start a little bit earlier, maybe 1 a.m. your time next time. Well, that's more verbose than I would like, but that's more correct than many of its comments have been. All right then. I hope that you have good sleep. I do not know the German word for sleep. Schön. Schön is beautiful. I don't know in German if that's the kind of adjective you would apply to sleep or not. Schön, 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 schön. I know a tiny bit of German. Okay, so now we have all of these. Let's see what Claude does. I've been using Claude to write my tests, and it's been doing a pretty good job. So, I will look at this marvelous comic that that is a funny XKCD. So one thing I would encourage you to look up is the Alameda, Weehawken, and Burrito Tunnel. This is a fantastic thing that is actually surprisingly little known, which is depressing to me because it's really quite amazing. It's an amazing feat of engineering. It's a tunnel that leads directly from San Francisco to New York, straight line. And one of the nice things about cords through the earth is that if they're frictionless, and you drop something in at one end of a cord tunnel that goes, as a cord, it takes a constant time to get from one end of the tunnel to the other. So through the middle of the earth, same time as if it's going along the edge of the earth. And that time is about 20 minutes. And so that means that if you have a this was like done in the time of pneumatic tubes. And so somebody basically made a pneumatic tube from San Francisco to New York, and they had a frictionless surface or very close to frictionless surface in there. Add a little bit of air and it's frictionless, and they just straight line distance. 20 minutes to send something from San Francisco to New York through pneumatic tube, and kind of fell out of use. It's not that useful to be able to send something that's that small through a tube, right? But it turns out that it was the perfect size for burritos. So you get the Alameda, Weehawken Burrito Tunnel. So I'm betting that all of these tokenizations are actually wrong. Like all of these require statements here are wrong. But that's okay. Then it probably gets the length wrong. But these do look like basically good tests. So it's mixing up different kinds of tokenization. Yep, there we go. It's got, yep. Those are good. Spaces, no spaces. Mixing them up. Yeah. Hey, I think this is it. All right. So we will just say, all right, apply. Let's add the tests. And then I will have to look over the tests more carefully and edit them into submission. But for now, yes. For now, this looks correct. So I think this is we want to accept all. So there we go. Now I'm going to have to go in, and it looks like it only added the tests, these tests, didn't do anything else. That's good. The little greens showing changed lines is great. It's very helpful. So how many tokens? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. So 16 tokens. It got it right. It's been forgetting to count the last semicolon oftentimes. So does it get this right? It's an X, followed by a less, followed by a Y, followed by a semicolon, and then A, followed by a greater than, followed by a B, followed by a semicolon. It's getting it all right. And then a C, followed by a less than or equal to. Yay! Followed by a D, followed by a semicolon. The numbers are all incrementing properly. Wow! I don't think it's gotten a test completely right before. And then a E, followed by a greater than or equal to. And then followed by an F, and then a semicolon. It's all correct. What do you know? The number of tokens, 16, 0 through 15. Wow. Okay. This one has a lot more tokens. Let's see if it got the right number of tokens here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Missed the trailing semicolon again. Okay. If open paren x less than or equal to 10 and y greater than or equal to 5, so 6, 7, 8, indeed, or z greater than 0, that's true, 10, 11, 12, close parent. Okay, then it's going to say result equals x less than y. So result equals operator, got it right, x less than y. And it doesn't check the trailing semicolon. Well, are there any semicolons in this at all that I can hijack? No, so I'm going to have to grab this semicolon. Like that. There we go. All right. Now, this one, 1, 2, 3, 4. So, 4 times 4. Each one of these is 4, 4, 16. It got the number of tokens correct. Well, that's very nice. I think after I run this test and verify it, that's it for me for this evening. I will be done at about 19. So A1, so we got A and then less than B. Good. Okay. then it doesn't check for the semicolon. Even though it demands that there be the correct number, we are still going to check for our semicolons here. And here it's going to be 3. C greater than D, less, greater than, less equal, greater than equal to, good. E less equal to F, G greater than equal to H. It's getting it all right here, except it's not checking for the semicolon. So here, this will be at 7. Here, this will be at 11. And here, this will be at 15. So that's all correct. And this looks correct. Okay, counting tokens again. 1, 2, 3, 4. 1, 2, 3, 4. So 12. Got 12. And here it is checking the semicolon for some unaccountable reason. So this all looks correct. Greater than, less. All right. This looks good. Let's see if it compiles now. Ooh, it compiles. Did I? Oh. 14, you say? 14. Why 14? It's 12. It should be 12. Something went wrong here. So we are going to change this to a check. And we're going to require there. So, nope, that failed. And then here, greater than or equal to. So line 715 here, it did not see greater than or equal to here. What did it see? It saw, well, that's very helpful. It saw 7 rather than 9. And we're going to change, we're going to go through here and change all of these to checks. I should probably do that with the rest of them too. And this one is, all of these ones are checks, right? The ones for the semicolons are all checks. Because we don't actually care, like the test isn't, the rest of the test is not completely invalid if this one does not contain a semicolon. For these, the require, if it doesn't hold the alternative, the correct alternative, then the following check is just is going to fail. or is going to actually cause a programming, a sig fault. But otherwise, it's great. And so we will run this. All right then. We are getting a lot of interesting failures here. Getting 2 extra tokens. What is going on here? Why are we getting the 2 extra tokens? And all of these started failing when they weren't failing before, which is very odd. But here we got this, and we get this where we're not getting the correct. And if we look here at our list of tokens, so we're expecting a 9, and we get a 7. So we're expecting a greater than or equal to, right? And so where is here greater than or equal to? And we get a greater than, not a greater than or equal to. Well, that's very interesting. So it's violating the maximal munch rule. Oh. It's not technically violating the maximal munch rule. So what we have to do here is we have to put all the multi-character ones before the single character ones. Like this. Why do we have to do that? Because apparently when you have a bunch of things that are ORed together in a regular expression, in this particular expression parser, the first one that matches is the one it takes. And so it was going, oh, I see a less than, I see a greater than. Yeah. There we go. Now it works. Yeah. When it has a bunch of OR alternatives, it takes the first one that matches. So you need to make sure that all the smaller ones, if the smaller ones could be prefixes of previous ones, they need, or if could be prefixes of other ones, they need to appear after all the other ones. So the safest thing to do is to put all the biggest ones first. Yeah. I don't like it. But there you go. It's one of the reasons why all the keywords I prefer the identifiers. So things that are keywords get matched as keywords in preference to identifiers. But I also have the negative look-ahead assertion here that they can't be followed by white space. Or no, negative look-ahead, positive look-ahead. Oh, they can't be followed by a word character. Yes, that's it. So, string is tokenized, I could change all of these to checks instead of requires. That's okay though. I don't really feel the need. All right. So one, gonna copy all of this text because I made a mistake. Log, because I did not want to not to check in the test and I checked that in by accident. So here's what we are going to do here. Basically make a temporary copy of this. Now hg commit -- amend. Leave the changelog message the same. There we go. Now it's only tokens.hpp, move foo.cpp back to test / Yay! We get all our tests back. Compile it. Good. Or run it. All of our tests pass. There we go. All right then. Do I want to continue much past? You know, I bet it wouldn't take too long to mock up the parser change. So, parser. Now when we're parsing an expression, parse sequence, parse stop, parse expression. Now parse expression statement is different from parse expression. And parse if else, parse assignment, parse statement, parse expression. There we go, parse expression. Now, one of the things we're going to need to do is, because an assignment statement can look like an expression, because equals could either be a relational operator or an assignment operator, because I did not separate the functions of the two in this language. Maybe I might change the language spec to separate the functions of the two, but right now they're not separated. So parse statement, we need to look at parse statement here. So for parse statement, we check for assignment before we check for expression statement. So that's good. So if there's an assignment statement, there is something where we have identifier equals something, that will be treated as an assignment statement rather than the equals relational expression. And so equals will only be treated as a relational expression in some place where it must be there must be an expression, which is like inside the parentheses of an if statement. So that's good. All right, so I don't need to worry about that problem. And here, parse bool term. Oh. Expected bool term parse imported. You know something? I'm not in the mood to fix that yet. But what I am in the mood for is fixing this so that we have, in addition here, we have yep. I missed a token. Well, well, well. And I missed a unary operator, but we're not going to worry about that right now. Nope. This is going to be another one part of the whole ugliness of everything. There. And that also means we need to add it to some of the tests too. But it's not operator less than, it's operator less. Yep. There is no operator not. Okay, I have them all. We have equal, not equal, less equal, greater than or equal to. I also have to update the grammar here to allow yes, like that. Less than, greater than, less than or equal to, greater than or equal to, equal or not equal. There you go. Less than, less. Yep, there we go. And I have to add that to the tests. So we have a whole big bunch of tests here. Not the, the tokenizer tests, right? That's fine. Like that. Okay. So I added a bunch of new tokens. 1, 2, 3, 4, 5, 6, 7, 8. Added 8 new tokens, so it's 28. And then here, this is great. Like this. And here we go, 20. Oh, actually, because the first thing is and then we have to check to make sure that it's the right keyword. Yep, just like that. And here, 21, and then 22, then 23, and then 25, and here we want here 26. So is this correct? So 20 should be else. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So yes, there should be 27. So what am I getting wrong here? X less than y, that's correct. And then a semicolon at 19, and then so else result X, or else result equal X, not equal Y, semicolon. So that should be 7 more. So the last one should be 6, 26. And do I say that? Yep, okay, this is correct then. Okay, it did not like something here. Something about this it did not like. What did it like? What happens if I do this? Still a failure. Okay. Did I fix tokens.hpp? Is caret a special character? Should I bet caret is a special character. Or not caret, bang. Okay. Less than or equal to, greater than or equal to, or not equal. What happens if I put the not there? Does it like that better? Okay. Oh, also, equal is no longer a thing. Okay, that's good. Not equal, got stuck there. Does not equal ever get used? Yes. It's not, and we check. Is it not equal? And we add not equal. Oh, there we go. So first, so diff stat. There we go. All right. That diff is what I expected it to be. Yes. All right. I'd actually be curious at some point in time to look at the code for this giant switch statement in here, because I bet this giant switch statement has some interesting looking code that is surprisingly tiny and perhaps very clever. So, yeah. Anyway, now we're done for the evening. I am not in the mood to implement the rest of this parser. I don't really have the mental bandwidth for it. The error that it's giving me is in fact not an error. Yeah, not an error. Yeah, I just don't have the bandwidth for it right now. So we're going to end the stream for the evening. I hope that you all enjoyed yourselves, and I hope to be back on Thursday. Yeah, Sunday or Saturday after that, and welcome you all back.